Hello. In this lecture, we will basically discuss some of the networking tools that are required to enhance our understanding of networking. These tools are quite important from the perspective of conducting experiments, and anything we do in networking, if we can conduct experience, look at how the packet flows, how do they go, and then see the results, and then verify with whatever protocols we study. This enhances our learning, and basically experience of seeing network in working in reality is what will help us our understanding. So it's good to have the networking tools. What we will discuss in our tools are: first we'll discuss netcat or called NC. Next we'll discuss ping called packet inter-network grouper. Then we look at a traceroute, which kind of uses ping. Then we look at two tools, wget and call. So let's get started. Let's look at NC. What really NC is? NC is called Network Cat on the Net. So it's the simplest tool that enables you to communicate using both TCP and UDP. Which we'll study much later in our course. NC can act both as a client and a server. That means I can use NC as a client, connect to any server, or I can use NC as a server and any client can talk to me. And it basically, NC gives me a simple transport over connectivity without any application layer protocol overheads. So as you said, support both. NC supports both IPv4 and IPv6, but for the moment, we'll focus our attention mostly on IPv4, not on IPv6. So few common use cases we can basically see: do a simple chat, run one server on a client, run run one NC server on one machine, run NC client on another machine, connect the client and the server, and do a chatting. What you do basically is in WhatsApp, you should be able to see in NC as well. So I'll give you examples there. How do we work? In fact, if you want to debug, let's say working with web protocol, would like to see how the HTTP protocol is working at the simplest level without using a browser or the browser developer tools, we should be able to communicate with any web server using simple NC, pass whatever headers you want to pass and work with those. If you use a browser, we cannot play with HTTP headers, but using NC, we can make whatever custom headers we want to send and do that. Other alternative is use some custom built applications like REST APIs or Postman or something of that kind. But at the simplest level, NC is most useful to deal with debugging network applications. We can connect to a network, other stuff. So let's say, how do we use NC? So if I want to run as a server, I would use minus option minus L. If I don't use the option L, it basically becomes a client. If I want to use it as a UDP, I need to use option minus U. If I don't use the option minus U, it becomes TCP. And same way, if I would like to put some delay in my transmission of packets, we can specify at what delay my packet should go. That becomes option I. And by default, when we run a server, when I run by default my server, it accepts only one connection closes. But if you want NC to be perpetually running, then we can use minus K option, and minus K option basically gives us the next server running. So if one client closes, and then it won't exit but continue. And we'll do both this demo. So let's look at a simple example of running NC. This NC is available by default on Linux or Mac machine. If you are using Windows, you have to probably download. They're free executable and source code available. You can install it, run it. But when downloading in Windows, make sure that if you have a 32-bit version of Windows, download a 32-bit version of NC or 60-bit version of NC, and both will work fine. So just to show us example, this is the example how the client runs. We use NC, server name, server IP address, and this server port number. And if server is running, it will try to connect to NC using TCP. If I want to run a server, I can say NC -L port number, which port number I want to use, and then it will run. If you are running Windows Server, NC server on Windows, Windows also expect -L to be separate and manage to specify port number, and that should work. So using both NC, and you can see that we can use NC to even transfer file. So let's look at the experience. We'll do a demo, a workout using NC on the same machine and using NC across the machines. So let me enlarge my window size so that you can see that things up. So this I am running on my MacBook. So if I look at, first I should know, I should run server NC -L, let's say port number 55555. Now my server is running, and since let me do communicate between same machine, so this is my client. I can say NC localhost, just let me clear so that we can be clearer. NC localhost 5555. I'm connected. Now whatever I type on one screen would appear on the other screen. So I'm typing on first on the client side, hello, hello. You'll see message coming up there. On the other screen, I'm typing on second screen, server screen, I'm typing welcome. You'll see message will go, sorry for typo, it goes welcome. I can try again, I'm back to the client. I'm saying, how are you? And you get a message on the server side. Now server can respond back, I'm fine, and so on, so forth. Now if I close a client, I can say press Control C or Control D. My connection is closed, terminated. My NC server also stops, and that way we're saying basically by default NC accept one connection. Now we can run NC. This was demo on a same machine, but let's run onto different machines. So I log onto my Ubuntu workstation. So I'll say SSH. I'm logging to my, so I logged into my Ubuntu server. So I want to note down my IP address. I say IP addr. You see my IP address is 10.211.55.10, and my client IP address is, if you can look at my client IP address, sorry, I'll see it because this is a working virtual machine. So you'll probably see somewhere my client IP address is 10.211.55.2. So let's say I run a server on my Ubuntu machine, NC -L 4444. So I'm running a server on Ubuntu from my MacBook. This is my Mac, and you can see this is my Ubuntu. So from Mac I connect NC 10.211.55.10, and since server is running on port 4444, I'll put a port number 4444, and this connection works. Now we're actually doing chatting between two machines. So this is my MacBook and this is my Ubuntu. So I would say hello, hello Ubuntu. I get the message on Ubuntu. When I say yes, how are you? You get a message back. And so see, across the network, you can do chatting. To demonstrate that, I did Control C, aborted, and my client also closed. Just to demonstrate that perpetual option that server shouldn't exit, I can use -k. I can say nc -l -k. So that means once one client is over, second client would start a connect, it will work fine. So let me start again. nc 10.211.55.10 4444, it connects. Hello, my first client connection. Message comes in. Sorry, this, remember there's an address there. It's not a wrong address, so I need to restart. I would say so. First client, remember here the error was I missed the dot and hence it went somewhere. So we'll explain that when we talk with IP addressing. So now this connected, server response, welcome first client. Now let's say about the client. I go to another client. This is my second client, nc 10.211.55.10 4444. Hello, I am second client, and you see this message comes in. So with the option of, if you look at, with the option of -k here, server continues to run as long as clients are there. If I respond, so on and so forth. I can exit, control D or control C, but server continues to run. In fact, NC can be used for most efficient file transfer. Let's say I want to transfer a file. Let's look at some file, maybe let's look at some file. So let's look at a file xyz.html. I want to transfer this file. So I can run an nc there, nc -l redirect to xyz.html. That means whenever server receives, it will write all the content into this file and say, so I'll run a client, I'll say cat xyz.html, pipe it to nc 10.211.55.10, port number is 4444, and you see my file is transferred. If I look at, it is the size 385. You can look at on the client side is 385 and with the same content. So this is the most efficient way of transferring file across two machines, and things would really work out. So this is the way of using NC. So let's go to the next. And we showed that something else can transfer a file. Other you should explain, other usages. Sometimes Windows machine doesn't close a connection and it remains, you don't know file transfer is not. So sometimes you want to put a specified wait time that if there are no network activity for few seconds, it should exit, and that is given by option -w. So -w10 means if a client does not see any activity for more than 10 seconds, it will come out, and that you can probably use with Windows setup of machines, but don't use server options. Similarly, if you want to access NC with web server, we can basically say NC website name, let's say rpurustigi.com, port number 80, because NC for any client. Remember, any HTTP protocol, when you get into those, all request response header lines should be separated by CRLF character. So if you're running in Ubuntu, -C enforces that every line is separated by CRLF. By default, Ubuntu sends new line character, or even macOS sends new line character, though Windows sends CRLF by default. So make sure that it ends. So after that, we send first protocol called GET. We say GET URL, which protocol you want to follow, called HTTP 1.1. Say which host you want to connect. This is HTTP header. We study those when we talk about HTTP, rpurustigi.com. Let's say this all we have to send in the request. Press one empty line, enter line. So basically returning one empty line, and then you basically get a response, HTTP 1.1, response received on 2nd October, and server Apache receive more such line. So you can actually use NC to talk to any TCP server or any UDP server as long as you know what is the protocol format to follow, and as long as you follow the protocol format, NC would work fine. Next we will look at is wget. So if you look at a browser, when you use a browser to access a web server, browser does two things. When you type a URL, it fetches the content and renders the content. If it's an audio file, plays the audio file. If it's a video resource, it plays the video. If it's an HTML file, it formats and displays a PDF. But if you just simply want to download the content and look at what is happening, wget is best tool. wget, again, you have to probably install it. Normally by default it's available Ubuntu, but Windows, again, you can download from SourceForge, any other known places. That's work fine. On Ubuntu, D is to debug headers. So these options we are talking for Ubuntu. So anytime I do -D, it will tell me the HTTP request headers and HTTP response headers. If I want to pass my custom headers, I can pass an option called dash header. To save a file, my output into a file, use the option -O. And but if I want to fetch multiple URLs, I can put them in a file and use that file name with -I. It will fetch all those. Let's say I have a slow link or poor quality link and I'm downloading, let's say, 100 megabyte file, and it breaks down after 40 megabyte, and we don't want to download again and start from starting. So if we use wget -C, it will start from the point where it has broken and resume from there. So in that sense, it's very useful when you want to download something on a little not so reliable or not so stable internet connectivity. By default, wget runs in the foreground, but if, let's say, you're downloading a large file and you want to download but you don't want to block a terminal, then use option -B to run in background. So we'll give a simple example and run things up. You don't want wget to use the entire internet bandwidth, because while running in the background, you want to keep browsing and you want to make sure that wget uses limited bandwidth. So let's say your link is 4 Mbps, but you want wget to use only 500 kbps, half Mbps. You can specify option limit rate to use only that much bandwidth, that not more, and that way you will not choke the entire bandwidth of the wget. And to pass custom header, you can use this. There are a number of other options. To understand the options, I would say use man wget and you'll get the man page, or you can say info and get these details. So let's understand how to use wget in our normal basic uses. Let's say I'll go back to my Ubuntu machine. I say wget so first I'll say wget, let's say simple my website. So say wget http://rprostagi.com. It will basically get the file index and save into current directory. So say it saves the file called index.html. But, and you can see this content, whatever content of the web file is. If you want to save into a file, I can say wget -o myindex.html. Now it will save the file into this file name and not by default what you're saying. So you say file name is saved as myindex.html. If you want to look at what headers being exchanged, because by default wget does not display the headers, so we can say wget -D. It will show you both request header and response header at the same time. So if you look at, these are my request header starting from get, default URL slash, protocol. These are request headers, empty line, so request is sent, and these are all my response headers. So in case you want to develop web applications and to look at how does header plays a role, you can access the same URL using wget -D, and it displays all the request headers. If you want to send very specific header, what you want to send, you can say wget -- header is equal to, let's say, host colon www.rprustagi.com, and then I can say http colon so I want to save but want to display only the headers, and I'm sending the request header, and I can actually even say debug. I can say -d, so it will send what headers I'm sending. I'll see my header, whatever host is going, and it will go there. So we look at my request header is host, whatever I send, that's the default headers, and my response was saved in file called w.html. So you can look at this my request. So that way, or if you want to mirror a particular website, you can use the option -nk. It will save the content from that URL and save things. So similarly, other tool we use is what is called curl. Curl is a tool that we use, so which is similar to wget. There are two different versions depending on what you're comfortable with. CURL stands for C and URL, that is client URL. So you can access this. There the option -e indicates the header in what response header you're receiving. By default it doesn't display the request headers. -I only shows response header. If you want to send your custom headers, you can use -H option. It will send, and then whatever headers you want to send, it will send those headers. And same way, so I can give a basic demo of the curl command as well. So let's say curl http colon it will display the content. By default, curl displays the content on terminal, while wget saves into a file. So look at it will display the content. If I want to see what the headers are there, I can simply give a option -i, and it will display the headers what we are getting. So you only see the headers what we're seeing here, and this is the way curl could be used. Other tool that we find useful is called ping. Ping primarily used for checking reachability, network diagnostics. At this moment, we just see the ping for reachability checking. Other options for ICMP protocol we'll discuss later. So ping basically different options. We can say ping some machine host name. It will send ICMP packets and receive a response. If it is a Windows machine, by default it sends 4 packets and then stops. Linux machine would keep sending continuously without waiting for it till you abort. By default, it sends a packet at the interval of 1 second. If you want to change the interval, use the option -i, and the let's say on Ubuntu by default keep sending infinite packets till you abort. If you want to limit a packet count, let's say I want to send only 3 packets, then I can use the option -c3. On Windows, if you want to send some fixed packets, you have to probably use for Windows option is -n. -n5, it will send only 5 ping packets and get a response. If you want to continue to send the packet, once you receive a response, send immediately without waiting. By default is 1 second, use F, but please use the -F option in a very limited circumstances because it could choke the network and create troubles, disturbance. So this should be used with caution. -Q option is just to look at the ping response without getting display for each response. So those who, if you want to monitor a NIC connectivity over the whole day or over a 1 hour, I just want to do -Q to give a summary at the end, and that's how ping will work. So we can probably look at few options how the ping works. Let me go to the ping. So if I say ping -C4 google.com, it will send 4 packets to Google, and so you're getting a response from Google. I'm pinging this. I can send something else. If I don't specify anything, it will keep sending packet forever without waiting this unless I abort. So I say Control C, it will abort. By default, it sends one packet every 1 second. If I want to change the interval, I can say minus I 3. That means it will send one packet minus C 4. So I'm sending 4 packets at an interval of 3 seconds, and then we'll get a response. So first packet after 3 seconds, second packet after 3 seconds, third packet, and the fourth packet, and then close. And see, it always gives you summary. It says 4 packet transmitted, 4 packet received. That means 0% packet loss, and total time is this much. And so, and this gives you the basically minimum response time, the average response time of 4 packets, the max response time, and the standard deviation of the 4 packets. You want to use a quiet option, ping minus Q, let's say minus C5. It will only give me a summary, but it will not give me the response. And after 5 seconds, I'll probably see the response of 5 packets. So let's look at how the packet loss, if there's a network loss, what happens. So I'll probably send, let's say, some 30 packets. I will not do a quiet option. Let me say I'll send 30 packets. And then in between, I break my network connectivity, resume it, and see how many packet loss happens. So I'm starting my ping. I start getting a response. I'm breaking my network connectivity. For the moment I broke my connectivity, it will basically time out. Nothing will happen. Let me resume my connectivity back. I resume my connectivity, let's say it's setting it up. It takes a while to connect. And then now things are resumed back. And you see things are working, and once we probably get all 30 responses, we'll probably get, so look at here, 30 packet transmitted, 14 received, because it was 16 packets, so almost more than 50% loss, so 50% loss time. So anytime if you want to check a network health, internet connectivity health, you can run ping for a half an hour, 10 minutes, monitor this packet loss, and tell you how good it is. And you can even see what the response time is. Total time is to 29 seconds, and you can say average response time is 305 milliseconds. So you can even look at how good your internet connectivity is using the ping options. And we look at other options. So I already showed you the options. This is what it displays here. We basically sees first packet response, second packet response, and then we'll basically see a summary of this packet where it says 0 packet received and next packet received, and so on, so forth. So we have more or less briefly discussed all our tools. So my suggestion would be to do a practical experience. So first exercise is take two systems in your home or office, go to lab, or you and a friend connect to some hotspot yourself. Let's say you make a phone hotspot, connect to it, connect to a network, run and see among the two of you, and can you do a file transfer, can you do a chat. So basically do chat, do file transfer among two machines, get a feeling. So one machine should run a server. So this is machine 1, connect either directly through a cable or through hotspot phone spot and run server, one machine server, one machine client, and do all kind of chat, file transfer, and understand how the NC works. Please, so as I said, for Windows machine, NC is not available by default. You can download that from this website, or you can look at any other website, which is a good site to look at and do that part. Next is connect to internet using hotspot or your home or something and play with ping. run few experiments, ping Google to see what the response time is, ping your own website, what the response time is, change the number of packets, look at the variation. You can even monitor the response time in daytime, nighttime, heavy traffic, and see how much variation you get of the ping when you do that. And let's send 100 packets, analyze the min response time, max response time, average, and standard deviation of a given. Also connect and to ping to the Google or any website and send about, let's say, 100 packets, 100 or 10, whatever you decide. Break your network connectivity for a few seconds, resume it back, and you should be able to study packet loss, and that way you can actually see how good your network connectivity is. Next exercise is use a trace route. Is a variation of your what is called ping. It basically tells you what are all the routers are available in a network. So you trace route to, let's say, google.com. It will display you all the routers in the path. So let's say I run a trace route, for example, trace route. So it shows me, if we look at first router, second router, third router, and so on. So there's the router at the fifth hop, router at sixth hop, and you see it sends 3 packets, and every time it takes a different path, so you can see what the different routers come in the picture, and you see all those packets. So use trace route to determine the number of routers between your machine and the Google, and trace route will work fine. Last exercise is do wget and curl. Use your own website, download few headers, make sure if you are using NC and CRLF, wget takes care of this by default, but if you are using NC, you can do that as well. Look at the headers, send custom headers, look at the response, and even try sending unrecognized header, make a bad request, don't separate the headers with a colon, and see how does it work. So in summary, what we studied: NC for netcat, chatting across two machines; ping to check reachability; trace route to identify number of routers between you and the server, for example, google.com; and the offline browsers, which basically get the web content and deal with that. Next, we'll study another important tool called wget, and that is what is called Swiss Army man's knife for networking, and that gives a lot of insight into network, can give each and every protocol. So looking forward to see you in the next lecture.